Okay, example number 2 has us thinking about how we graph functions with a base of e. So if we consider the function g of x is equal to negative 2 e of x minus 3 plus 2, we want to think about what do we do with all these different parts that are kind of adding on to our basic um, graph. So e to the x looks like this. If I did 2e to the x, then that would just double everything. So rather than getting 1 here, I get 2. Rather than getting, at looking for 1 here. Instead of getting, well, you get the idea. All of our values double. All of our y values double. If we want to arrive at all the same things, but we want to get to them a little bit quicker, we shift the x up here, either to the right or to the left. So like if we do x plus 1, well, then we're getting to all those values a little sooner, right? Rather than waiting until you're out at, instead of waiting till you're at 0 to get an output of 1, you get that output at negative 1. I'm trying to get here, yeah, negative 1 and 0. Oh, it's on there. If we want to go the opposite way, then we'll subtract. So we'll get there a little bit later. We'll have to put in a larger value of x to get to the same place that we were before. If we want to just take our equation, our graph, and we just want to move it up, well, we can just add to it. If we want to move all the values down, we can subtract. Okay, so most of this is the same as any other kind of translation that you'd be doing. So here they're saying a equals what? I believe that's going to be negative 2. If I had to guess, kind of haven't looked at this ahead of time, but if I had to guess the basic formula, they're probably just going to use A, B's, and C's for it. So it's going to be something like, well, they have H and K there too. So let's figure that out. I believe A is your first one. So you have A e to the x minus, K is 2, H is 3, so minus H plus K. That's kind of your basic exponential, E-based exponential, or any kind of exponential, I guess. You have a stretching factor vertically, you have a shift left and right, and you have a shift up and down. Okay, the graph is reflected in the, well, what does that mean? Reflected in the what? And stretched by a factor of 2. I'm not sure what they're looking for on all those. Let me just look at cheat sheet over here. Right, okay, so A is negative 2. It's reflected over the x-axis and stretched vertically. Okay, that's what they're looking for. H equals 3 means the graph gets translated 3 units to the right. So when we do x minus 3 up here, that moves us 3 units to the right. And the plus 2 moves us up. Okay, so if we wanted to show those one at a time real quick, the first one takes our graph and flips it and stretches it. Well, let's just do it over here. First one flips it and stretches it. The next part translates it over. Oops, I gotta put parentheses. It moves it over a little bit, and then the final part moves it up. And I think that's all we need. Well, domain and range. So looking at this, the domain, well, there's no x values that we can't use. They're all fair game in this one. Right, we can use all the x values we want. The range, however, is limited by whatever this asymptote is. So it's going to be all numbers less than 2, it looks like. Yes. Okay, find the average rate of change over this certain interval from -4 to -1. All right, well, at -4, we are basically at 2. We'll just call it 2. And at -1, we are at 1.963. So I think we have a change of, what's that change? 0.035, and it's over a distance of 3. So, here we go. It's right there. So we have a change of 0.035 over a distance of 3. That's your rise over your run, your change in y over your change in x. So then you just simplify that number. Based on the graph, the curve appears to pass through approximately 0, 2, and 3, 0. So the average rate of change for that interval would be negative 2/3, right? Down 2 over 3. Yep, negative 2/3. They have us check it precisely. I'm going to get very close to negative 2/3. The graph is very steep for values greater than 4, right? As we're coming out, around here, this region, it gets very steep. So the average rate of change from 4 to 8 should be it should be a negative number, right? We have a negative slope. That's what it means to have a rate of change. It's your slope with a large absolute value, right? So ignoring the negative part, the size of that slope gets really big. Okay, so if you'd like, you can go through on these ones on your own through the book, just to kind of solidify some of that. Otherwise, take a look at the next video, for example, number 3.